minutes after I took a piece of sugar in my mouth, I put a piece of sugar in my mouth, the pH level drops to a minimum of 4.8. According to the graph, what is the normal pH level of the human mouth? According to the graph, what is the normal? What does the function try to attain at all times?
That be 6.5?
Indeed, that's it. That's the horizontal asymptote. Perfect. What is the equation of the horizontal asymptote associated with this function? Y equals? The horizontal asymptote is y equals?
.5.
That's it. Y equals 6.5. Indeed. Use the graph to describe what happens to the pH level during the first hour. We already did that. My pH level in my mouth is 6.5. I swallow a piece of sugar. Boom. It drops to, in 6 minutes, it drops to 4.8. And then assuming I don't continue to swallow whatever with sugar, then it will eventually, in about an hour or so, get closer and closer, closer and closer to the normal pH level of 6.5. Okay, next question for you. We want to look at 102, or we want to graph another slant asymptote, or both. Just wanted to see if there is anything that follows. Okay. We want to look at 102. It has 3 parts. Anybody, please? Anybody with me?
Can we do both, like you said?
Good. Okay. So 102. A drug is injected into a patient, and the concentration of the drug in the bloodstream is monitored. The drug's concentration, C of T, C concentration, T of time, in milligrams per liter after T hours is modeled by a type 2 equation function. The graph of this rational function obtained with the graphing utility is shown here. And they're giving us the viewing window. 0, 10 with a tick of 1, 0, 3, 0, 3 with a tick of 1. Use the graph to obtain a reasonable estimate of the drug's concentration after 3 hours. 1, 2, 3. 1, 2, 3. Reasonable estimate from the graph. Anyone?
Like 1.5?
That's it. Perfect. Use the functions equation displayed in the voice balloon by the graph to determine the drug's concentration after 3 hours. Fine. 5x over x squared plus 1. Oops. 5x divided by x squared plus 1. And they want us to plug in 3. Okay, fine. Exactly what you said. 1.5 milligrams per liter. Perfect. Part C. Use the functions equation to find the horizontal asymptote for the graph. And describe what this means about the drug's concentration in the patient's bloodstream as time increases. Can anyone give us the horizontal asymptote for C of T?
0.
Yes. What does that mean? that if we only take one injection and we don't continue at set times, we hope that eventually what happens to the drug's concentration in the bloodstream as time goes by? It approaches. Eventually, it approaches. Yes, that's the horizontal asymptote, indeed, 0. We certainly hope that we get rid of it. It was good, we needed it, but then we hope it's gone. Yes, very good. Okay, now let's go back and choose another slant asymptote situation. Remember, the degree of the top has to be by 1 unit higher than the degree of the denominator. So let's choose another slant asymptote. We worked on 85. And let's choose another and then move on to the last section of this chapter.
We do 88.
Yes, let's do 88. Perfect. In 88, we have f of x equals x to the third minus 1 divided by x squared minus 9. Perfect. Perfect pick. Good. We have to factor at least the denominator in order to identify the domain. And I will also make myself a note, type 3 slant asymptote. Perfect. So, can anyone give us the factor form of the denominator?
X minus 3.
Very good. Can anyone now give us the domain of this function? Domain? Anything but?
3 and negative 3.
That's it. Good. They don't disappear. Good. Can anyone plug in 0? What do we get? When we plug in 0?
One over 9.
That's it. They are vertical asymptotes, but we don't know the sign. The sign will be determined left and right, negative 3.1, negative 2.9, 2.9, 3.1. So because it's a little bit more involving, let's say, to calculate, please plug in this function in the graphing calculator and then plug in these numbers. And just give me the sign. Only the sign. So put the function in the graphing calculator as you see it, or here, but with parentheses, don't forget. Parentheses are on the top, parentheses are on the denominator. And plug in negative 3.1, plug in negative 2.9, plug in 2.9, plug in 3.1, and just give me the signs. Please, everybody. And then we're going to deal with the slant asymptote, and it's done. We do have an x-intercept, though, to calculate. Do we have any of the signs?
So it's the left of -3 is going to be negative.
So I got negative here. I got negative here, negative here. Yes, I agree. Very good. With negative 2.9. What did we get with negative 2.9? Please try it. This is negative, and this is positive. So the sign is?
Would it be positive?
Indeed, very good. With 2.9. With 2.9, this is positive. This is positive, but this is
It would
negative.
go negative.
Yes, I agree. With 3.1, this is positive, this is positive, this is positive. Good. Perfect. Now, when is this 0? You remember a fraction is 0 when the top is 0 for the for the x-intercept. Y is 0 means x cubed equals 1. So this is x equals 1, which is right here. 1, comma 0. Finally, this slant asymptote. We have to divide. Careful how we divide. It's only the long division. We cannot use the synthetic division. So f of x equals x cubed minus 1 over x squared minus 9. Long division. X cubed minus 1, x squared minus 9. Good. So let's start. There are missing terms. Degree 2 is missing and degree 1 is missing. Good. So x squared times what is x cubed?
X.
Good. X times x squared is x cubed, but we have to change the sign. X times negative 9 is negative 9x, but we have to change the sign. 9x minus 1. This is it. Stop. X squared does not go into 9x. So the answer is x plus 9x minus 1 over x squared minus 9. This is type 2. Eventually, this will approach 0 at infinity. So that doesn't mean anything to us. This is the slant asymptote. So y equals x slant asymptote. Does it look like this? Or does it look like this, the slant asymptote? Because this will give me the end behavior of the function. Which one? Like this or like this? 1 or 2?
1.
Yes, because it's the leading coefficient is positive. So negative infinity to infinity, y equals x slant asymptote. Again, it's a lot. I'm making it easy, but it's a lot. Okay. When we graph functions with asymptotes, we graph the asymptotes first. The function has 1, 2, 3 asymptotes. 1, 2, 3, 1, 2, 3. Y equals x. We know how to graph that from transformations. And now we read the table. From negative infinity to negative infinity. Really? What does that mean? It means this. From approaching the slant asymptote to a maximum, coming down to negative infinity on the left-hand side of the first asymptote. Then, it's coming from positive infinity, crossing at 0, 1/9, very difficult. And then it crosses at 1, 0, and then it goes to negative infinity. Now, I know what this looks like because I teach calculus, but it's kind of difficult for you to understand how this looks like because you haven't seen this before. So it's coming from positive infinity, crossing. Somewhere it has to change and come down, but we don't know in this class. Okay, so that's why I'm saying this is a sophisticated situation. Okay, and the function does this. So it comes from approaching the asymptote, crossing the y-axis, crossing the x-axis, and going towards negative infinity on the left-hand side of the second asymptote. And again, of course, infinity to infinity, how is that possible? Again, here, how is this possible? Well, in the same way. It's coming from positive infinity. It has to come down to a minimum, and then it approaches the slant asymptote. So that's what I'm saying. I show you, we'll go over this. It's interesting to, to graph them, but I think I will not put a problem like this on the test. Maybe, an extra credit to choose from or something. I will ask you to determine the slant asymptote. That's definite. But graphing something like this is not, I don't think it should be part of this class. This is a more sophisticated. Here, when I graph this with my calculus students, I show them something called an inflection point, opening up and then opening down. That's a point somewhere here where the function changes concavity. This is way more sophisticated than algebra. So, but it's there. The department decided that needs to be discussed. I am discussing them, but the slant asymptote, I think it's a little bit stretching it. So I will not put this on the test or the final. We had x cubed. Minus 1. So a problem like the two that we discussed, 100 or 99 and 102, something like that, yes. With type 1 and type 2, yes. But the slant asymptote to graph, no. I will ask you whether the function has a slant asymptote, and please find it. But the whole spiel with graphing it, I think it's beyond the scope of the course. Okay, so I'm going to use the standard. It may or may not work. I don't know. We'll see. Okay, it did work. So we have vertical asymptotes at -3 and +3. The function does whatever. It's hard to see here. It comes to a maximum as expected and then comes down. It comes to a minimum and then goes up. And I can determine the maximum with second and max. Maximum is 4. And I want, what do I want? I want, let's say, -7. And then I'm going to drag past the maximum, press enter, and enter again. Okay, so it's the maximum is at -5.2. I'll put it in the table at -5.2, and it's -7.8. And I also want to determine this minimum. So second in calc, I want the minimum, which is 3. And I want the minimum to be, so this was 3. I'm going to say 3.5. Okay, and then I'm going to drag past the minimum. Okay, no guess, give me the minimum, 5.2. And the minimum is 7.7. Yeah, I think this is overdoing it. Determining whether this is type 3 and finding the slant asymptote, yes, but the whole Spielberg graph, I will not put it on the final exam or test. It's good, as I said, to understand these functions.